Today, we are going to walk through how to find a sensible heating load due to infiltration on a cold winter day. A residence has an estimated infiltration rate of 0.5 air changes per hour in a volume of 20,000 cubic feet. We'll draw the house, show the air coming in, and mark the information we know. We are told the indoors is set to 70 degrees Fahrenheit, and the cold outdoors is just 10 degrees. We'll use these details and the sensible heat equation to find how many British thermal units per hour the furnace must supply for the leaking air. Now, we need to convert that air change rate to a volumetric flow rate, which is CFM, or cubic feet per minute. The formula is CFM equals ACH times the volume divided by 60 minutes. Plugging in our numbers gives CFM equals 0.5 times 20,000 divided by 60, which is about 166.7 cubic feet per minute. This is the amount of air leaking in per minute. We now use the sensible heat equation for air, which is Q sub S equals 1.08 times CFM times delta T. Delta T is the temperature difference between indoors and outdoors, 70 minus 10, which is 60 degrees. So Q sub S equals 1.08 multiplied by 166.7 times 60, giving us 10,800 BTU per hour. The answer choices given are 5,400, 7,800, 10,800, and 14,400 BTU per hour. From our calculation, the correct option is C, 10,800 BTU per hour. This is exactly the value we found for the sensible heating load due to infiltration, so we can confidently choose C. To summarize, convert the air change rate to cubic feet per minute, then use the sensible heat formula Q sub S equals 1.08 times CFM times delta T. With our numbers, we get a sensible heating load of 10,800 BTU per hour, which is option C. This result matches the reference from the NCEES Handbook on Infiltration Loads and Sensible Heat Calculations.